All right, so this is for Flex Friday for B-Day on February 19th. We're going to finish the notes that we started in class on, I guess it was Tuesday. So let's do number 2. This is another one like letter D, where we're going to do factoring. And we're going to go ahead and we're going to follow the steps that we have at the bottom of the page here. The first thing we have to do is set our quadratic equal to 0. So in order to do that, I like keeping my x squared or my sine squared positive. So I'm going to move both the 1 and the sine of theta over to the left side. So when I do that, I'm left with 2 sine squared of theta minus sine of theta minus 1 equals 0. And now is where I have to do my factoring. But actually not factoring yet, I'm so sorry. Second step, we're going to let x equal cosine, sine, or tangent and rewrite the problem. So in this particular instance, I'm going to let x equal sine of theta. And so this rewritten equation would be 2x squared minus x minus 1 equals 0. Now, my third step is to factor. And I know the only way to get 2x squared is 2x and x. And the only way to get 1 is 1 and 1. But notice it's a negative 1, which means I need one of my signs to be positive and one of my signs to be negative. Like we did on the first example, I just always start by trying plus and then minus. And then I check it. Here's how I check it. I check to see, I know it's going to give me the negative 1 because positive 1 times negative 1 is negative 1, but what I need to make sure is that I'm going to end up with that negative x in the middle. That's what I've got to double check. So I've got to double check my outer and inner terms. On my outer terms, I get negative 2x, and on my inner terms, I get positive 1x. And when I add positive 1x and negative 2x, I get that negative x that I was looking for. So I know that I'm finished and that this is the correct factoring. I'm finished the third step. If for some reason I had a positive x, then I'd need to switch these signs and put the negative sign on the left factor and the positive sign on the right factor. But the way I have it factored works. So now I go to my fourth step where I put cosine, sine, or tangent back in. Be really careful that you put the correct word back in. If you put cosine in or tangent in and it's supposed to be sine, you're going to get different answers. So you've got to look at the original problem. This fourth step is really important that you put the correct trig function back in. So now we're going to have 2 sine of theta, that's what the original problem was, plus 1. And I'm going to have sine of theta minus 1. Still equals 0. All I did was substitute back in the x equals sine of theta. Now I have to solve each factor separately. So 2 times the sine of theta plus 1 equals 0. And then I have sine of theta minus 1 equals 0. Okay. Going to solve each of those. Subtract 1 from each side, and I get 2 times the sine of theta equals negative 1. I'm going to divide each by 2, and now I get that sine of theta is negative 1/2. So theta is going to be the inverse sine of negative 1/2. This is where I go to my unit circle. I go to the entire unit circle. I'm not just going to go to the part of the unit circle that is for inverses because I put inverse in there. which means I'm using all of my unit circle from 0 to 2 pi. If you look at the instructions here, it said find exact solutions from 0 to 2 pi. So this is where I'm going to pull up a unit circle. And on my unit circle, I'm looking for sine, which is the y coordinate, to be -1/2. I notice on yellow on my unit circle, in the first quadrant, I have a y coordinate of +1/2, which means I'm going to stay on yellow because the number part is right. Even though I don't want that +1/2, I go over to quadrant 2, I still have a y coordinate of +1/2. I go down to quadrant 3, and there's my y coordinate of -1/2 at 7 pi over 6. And I go over to quadrant 4, and I have another -1/2 at 11 pi over 6. So my two answers are 7 pi over 6, and I'll highlight this so you can kind of see how I have that -1/2 there, and I have a -1/2 right here. And so it's 7 pi over 6 and 11 pi over 6. So I'm going to put those answers down as 7 pi over 6 and 11 pi over 6 right here, and I'll highlight. Those are two of my answers. That's from my first factor. Now I have to go to my second factor and add 1 to each side. And I get that the sine of theta equals 1. Take the inverse, and I get theta is the inverse sine of 1. So I'm going to need to go to my unit circle, and I'm going to need to look for where my y coordinate is going to be 1, because sine, remember, is 1. So I go to my unit circle, and y coordinate of 1, I see that up at the top of my unit circle up here. I see a y coordinate of 1, and that's at pi over 2. I look at my other than 4 corners, and down at the bottom it's -1. I don't want that. I want +1. So the only answer I'm going to have here is going to be pi over 2. So I'm going to go back to my where I was solving my equation, and I'm going to write pi over 2 is that other answer for that one. All right, the next thing we're going to look at are the equations that we had skipped before in our notes, where it asked us to find, for each equation, find the approximate solutions for between 0 and 2 pi. Now, when we do that, approximate means we're going to use our calculator, which we usually think means easier. This is the one time where most people think the ones on the unit circle are easier, because you can just look at the unit circle and all the answers are there. And notice it's the calculator for between 0 and 2 pi, which means right now you need to put your calculator into radians. So I'm going to do that with my calculator. I'm going to go to mode and make sure that I'm in radians. One of the things that I always do when I do these problems, because I want to have the calculator in radians and I'm doing estimates, I draw myself a sketch of a unit circle, and I do approximate radians at the 4 corners. This is 0. Up at the top would be pi over 2. So on my calculator, I hit pi, the pi button, divided by 2, and I get approximately 1.57. And then I come over to the left, and if I just hit the pi button on my calculator and hit equals, I get 3.14. This is just a reference circle that I like to do. Then I'm going to do 3 pi divided by 2, and I get 4.71. And then I do 2 pi, hit enter, and I get 6.28. That's going to help me when I'm looking for my answers to know where they should be based on the number that they are. Now, when we're solving these equations, what we need to do is we need to solve the equation, and determine, this is the part that's really important, determine which quadrants the answers are in. Okay, so let's look at number 1. It's a one-step equation. We take the inverse of each side. And I get that theta is the inverse cosine of 0.8. Well, as soon as I do that, this is where I need to determine which quadrants my answers would be in. Normally, on the other problems, I would just go to my unit circle and I'd look for where's the cosine 0.8. We don't have this one on the unit circle, so I've got to determine, well, if it was on the unit circle, where would it be? Well, because the cosine is positive, I know that positive cosines are in quadrants 1 and 4. So I know that I'm going to have a quadrant 1 answer, and I'm going to have a quadrant 4 answer. So now I use my calculator, second cosine, 0.8, and I get that theta is I'm going to go to 4 decimal places, 0.6435. So that is one of my, oops, meant to hit my highlighter. One of my, keep doing the same thing. Let's erase that, rewrite that. Theta is 0.6435. And I'm going to put that right here. That would be my quadrant 1 answer. If you notice, 0.6435 would be between 0 and 1.57, which is quadrant 1. So that means this angle right here is 0.6435. Now I need to find the answer that's down here in quadrant 4. Well, how am I going to find that? I'm going to take 2 pi, and because I'm going the other direction, 0.6435, I'm going to subtract the 0.6435. So in my calculator right now, I'm going to type in 2 pi minus 0.6435. And I get 5.6397. So 5.6397. And if I look at my unit circle that I drew above, 5.6397 would be in quadrant 4 between 4.71 and 6.28. Let's go ahead and do number 2. We're going to subtract 5 from each side. I'll do this in a different color just since we're kind of getting tight here. And I get 2 times the tangent of theta is 3. I'm going to divide both sides by 2, and I get that the tangent of theta is 1.5. So theta is going to be the inverse tangent of 1.5. So again, I need to draw my unit circle and determine where would tangent be positive. It would be positive in quadrant 1 and in quadrant 4. So using my calculator, second tan 1.5, I get theta is 0.9828. That would be my quadrant 1 answer. And remember, when I am on a diagonal like that, remember a straight line is 180 degrees or pi. So to find the other answer, I'm going to take 0.9828 and add pi to it because I'm going halfway across the circle. So on my calculator, I hit 0.9828 and I add to it pi. And I get 4.1244, which is indeed in quadrant 3. It's between 3.14 and 4.71. Those are my 2 answers.